We have our next speaker. Please welcome Gergely. Let's welcome him with a round of applause. He is going to talk about resource monitoring and optimization with Metaflow. So I will give over the mic to him, and you can start.
Perfect. Thank you so much, and thanks everyone for joining this session. I know it's getting pretty late and getting into the weekend. Excited to be one of the last speakers today. So this is about resource monitoring and hopefully optimizing that, and try to come up with a way so that you do not have to do much other than installing a Python package and making use of that without a lot of manual tuning. But before we get into the details, I wanted to bring some credibility for this project, because I'm pretty sure you have never heard about spare cores before, so that you can trust this project and maybe give it a try. So this was started 1.5, 2 years ago, thanks to an EU grant. If you have not heard about NGI Search, check that out. It's an easy way to get funded for open source project that makes impact. So I'm really grateful for that, so that we could kickstart this and we could work on a cloud vendor independent, transparent database of cloud servers and coming up with open source tools to make the most out of it. So this is dedicated and will remain to be open sourced. We were also accepted into some other programs, and thanks to that, we managed to get around $100,000 cloud credits so that we can test some of our things at scale, and we can also benchmark cloud servers in the public. I will include a slide regarding that later and share with everyone for free. This has been presented at a few conferences, and we also had some good rides online as well, like on Reddit. We were featured by the Pragmatic Engineer last year and got some good feedback. About the project, so this is a collection of open source tools related to using cloud resources for data science, machine learning, AI, and so on. We have built tools which can create an inventory of the cloud servers, including pricing, the specs of the servers, all the availability zones, regions, traffic prices, storage, the characteristics of that, and so on. And it not only includes the marketing specs shared by the vendors, but we actually start all the machines. So we have spin up close to 2,500 different server types at the hyperscalers and smaller European vendors as well, like Hetzner and UpCloud. We have run hardware inspection tools on all those machines, and we have run close to 1 million benchmark workloads, things like memory bandwidth or running databases like key value store as Redis, for static web serving some workloads, or look at that, OpenSSL speed, and so on. More recently, we did some LLM inference speed benchmarks for prompt processing, text generation using small to larger models, like 135 million parameters up to 70 billion. All these were run in the public using GitHub Actions. So we actually started all the servers in GitHub Actions. You can see the output, and all the results are recorded in GitHub repos, so you can get the raw data if you wish. And we also publish all these in a structured format, so you can download the SQLite file, which is getting sizable. It's around 700 megabytes, including all the benchmark data that we have collected, but you can grab it and take a look and figure out which server might make the most sense for your use case. We have also created web applications so that you can browse that data. We have APIs, public and free APIs, so you can just hit that A point and find a server which might be the most cost-effective for a workload. There are also SDKs and so on. So if you're interested, go to sparecores.com and find that there. And there are some also related open source tooling. And for today, this is more important, the resource tracking Python package, so that you can record some patterns of your Python or R or whatever scripts. If those can scale to multiple CPUs, if those can use multiple GPUs, how much VRAM you need, and so on. And then you can put together that data with the data set that I shared previously and find the most cost-effective or the most performant server in the cloud to run your stuff. I will focus on some examples regarding Metaflow. If you're not familiar with Metaflow, I included a slide which tries to summarize what's this. It was started at Netflix and been open sourced for quite a few years. It's being maintained by the Netflix folks and also by Outer Bounds. You can use that from Python and R as well. And the main focus of this project compared to other competitors was that it's a human-centric framework created for data scientists who can write their workflows, build up the different steps, and things are taken care of in the background automatically for data scientists so that they do not need to think about how to scale things to Kubernetes and so on. So they create the workflow, and then Metaflow will take care of deploying things at AWS Batch, Kubernetes, whatever, regarding the resources you need. It also takes care of versioning artifacts automatically and so on, so there are some pretty cool and nice features. A quick example here, and I borrowed this from like the Metaflow docs. You import the flow specification. You create a flow specification by subclassing this. Then you create the methods which will be executed. So we will have start, hello, and end. You use the step decorator, so that's how we signal that these will be the steps of our flow. And then the D from the DAG comes from directed, so you point which step is to be executed next. And here's the body of the actual workflow. We are just printing stuff. And after calling this, here's the super simple DAG, linear, going from start to end, having an intermediate step. This was a super simple example. I wanted to do something more fancy that can be digested better by data scientists and machine learning engineers. I really love D&D and throwing dices. At the beginning of today, PyData was already mentioned, so I thought that would be a good introduction for a more advanced Metaflow example. So here, there's this dice roll flow specification. We have an attribute where we, where we define the number of sides a dice can have, and in the start step, we will decide what kind of dice we will roll. So just sampling from that list that I mentioned previously, and we will also define the number of times we will roll. Later on, we will do the actual rolling, and you can see from the list comprehension that we will have a list of some numbers. So this is a bit more complex DAG, and we will iterate on this later on. What I wanted to highlight is that you can see that we set some attributes here, and those will be actually stored by Metaflow as artifacts. By default, if you're running this on your laptop without much configuration, that will be stored on your file system. But you can use an object store, and things might be pushed to S3 or whatever object store you define. And different versions of your artifacts will be maintained, which is super useful when it comes to debugging, like not only looking at the job outputs, but you can actually see what was in your variables at the time being and how it was manipulated later on. So this is the result, or sorry, the output of one of the runs. And what I wanted to highlight here, you can see that the start step was running in a process. The second one, where we were actually rolling the dices, that's using another process, not having access to the variables defined in the previous one, so you can only use the artifacts stored from the previous one, and so on. And this is useful not only on your laptop, but when you're running things at scale, like Kubernetes, AWS, Batch, and so on. Then things are written to S3 or other object store, and you can create a step in R, another step in Python, whatever. You just have to make sure that things are serialized in the back end. Also, you can look at the details of all the workflows, all the runs and the steps. For example, here I'm looking at the most recent successful run of the dice roll flow that I've just defined and run previously. Of course, you have access to metadata, like when this was run. You can see the actual data. So if I go back, I can see that on the standard out, it was logged that we rolled 3 times with a D10. And that's actually stored here as a list. You can also look up the separate steps of a workflow, look at the metadata of that. You can see the standard out, standard error, and all the tiny details of those tasks within the steps. And you can see different versions of the artifacts as well. So here's a more complex case. It's not a linear one, but actually we are training a model A and a model B at the same time, and we are doing that by executing fit A and fit B in parallel after the start step. What I would like to highlight here is that we are passing the same data to fit A and fit B. Those are returning different models that we combine in the evil step to the best model. So you can join all these artifacts, define what you want to do with those, and you can do even more. Like more recently, the recursive steps and conditional steps have been also introduced, so that's super useful for many cases. But for the sake of resource tracking, I think what's more useful is that you can define all the dependencies for the different steps. You can use the PyPy or the Conda decorator and define which version of Python you would like to use for a given step, which packages you need, even the package version. So you can use pandas 1.0 something in a step and 2 point something in another one and so on. So it's all up to you. And the most exciting part, at least for me, is that you can define where the steps are to be executed. So maybe some part of your workload can run on a shared machine because it's not really using a lot of resources. Maybe just running a SQL, it doesn't need CPU and memory and so on. But later on, when you're training a hierarchical model, which might need hundreds of gigs of RAM on a single CPU core, or you need multiple GPUs to do some image processing, then you really have to scale out things. You can use the batch decorator or Kubernetes decorator, and you can define the amount of resources you need. And hopefully this also reflects why I said that this is a human-centric framework. So data scientists can just provide their definitions here. No need to tweak YAML files at all. They are writing Python code. Python decorator will define how many CPUs I need. On the other hand, how do you know that you need 32 CPUs or maybe 36? Or looking at the memory usage. Usually we just over-provision because we do not want to get notified on a Friday night that some script run out of memory, so you can waste a lot of resources. So what I suggest here is to have some automation so that you monitor the resource usage of those scripts. And I think humans should not really touch these things. It can be auto-tuned if you are retraining things from time to time, then the historical data can be used to figure out what is required for a future run. So here comes the resource tracker to the rescue. This is a lightweight Python package, which is actually zero dependency if you're using it on Linux, because it's just relying on the modern kernel. Well, it's using the proc file system. If you are on a Mac or Windows, so probably not running things in a production environment, then you still need psutil to be installed, but that's it. Other than that, there are no requirements. And this was useful because this thing has been deployed in some very strange environments where you cannot even suppose that anything is installed other than, let's say, Python 3.9. So it will monitor the resource usage at the system level, so all the resources used on your laptop, on a server, whatever. And it can also focus on a single process, optionally all the children processes of that single process. It looks at the CPU usage, so time spent in user space and kernel, looking at the memory usage, looking at GPU and VRAM usage, and it does that at the process level as well. So if you have a server with multiple GPUs running multiple processes, then it can automatically log you which process was using which GPU and how much VRAM was reserved. Network usage, so bytes in and out, disk I/O, storage, and quite a few other things. It doesn't suppose you to spend a lot of time on this. So once you import the package, you are kind of all set. It runs in the background, so not blocking the execution of your Python or R script. It will spawn a separate process and keep an eye on your processes. And there are some framework integrations, and I will highlight Metaflow now with a few examples. If you would like to use as a standalone one, install it from PyPy, and this is a minimal example. After importing, then you create a tracker, you do some stuff, and then optionally you stop the tracker and look at the report. So we are not looking at the raw data at this point, but focusing on the report that you can generate pretty easily. This is an example report that I've created previously, so this is something you can generate very easily. What this includes, some specs about the server or your laptop that's executing the code, so it will do some hardware discovery and cloud discovery as well. So it will be able to figure out if you're running this on AWS, Hetzner, UpCloud, whatever. It will find the region if it's possible using the metadata servers, looking at the instance type, which is important so that we can look up the public pricing, and later on when we recommend another machine, then you can see the potential cost savings compared to the currently used machine as a relative percentage and absolute money saved. Then you can see some usage statistics, including average CPU or the peak memory usage or historical memory, and so on. Same for GPU, incoming, outgoing traffic, and so on, and the detailed chart for CPU, memory, GPU, traffic, storage, and so on, so you can see what happened while you were running this script. The most important part is the recommendation. Based on the aggregated statistics, it will recommend that, okay, your script doesn't seem to scale well to multiple CPUs, so just don't bother reserving more than one. You are okay with a gig of memory, and you are actually using a GPU but cannot scale to more. So these are the minimum specs that you need, and we will find automatically the cheapest server for those specs. If you are interested in the actual data, of course, you have access to that. And as I mentioned, this is a minimal or actually zero dependency package. But instead of dealing with all the dictionaries, it comes with a tiny data frame implementation so that you can get a nicer view of the tables, you can do stats, and so on. Just to highlight, of course, you have timestamps when all these metrics were recorded, number of processes run on the machine, time spent in user space, and by the kernel in system. You get the CPUs utilized, memory-related metrics, disk traffic, GPUs, and so on. So you can look that up. By default, the sampling frequency is 1 second. You can set whatever you wish. Regarding the process metrics, this is similar to the system metrics, but now we are focusing on the number of children processes, and very similar metrics are being recorded. Unfortunately, not all the system-level metrics are available at the process level as well, like recording the number of bytes received and sent is pretty difficult to track, also when it comes to the storage metrics. So that's only available at the system level. There are some helpers to combine all these data into a single data frame with some helper flags, like you would like to see human-friendly names instead of the underscores. Maybe for data visualization, you can do that very easily, so you get data frame like this one. Instead of looking at the raw data, you can generate stats pretty easily. By default, it will look at the average and peak CPU, memory usage, and so on, with duration and a few other things. Check out the docs. You can totally fine-tune what kind of statistics you are looking for. Once you have the aggregated stats, then you can use those numbers to come up with recommendations. For this one, it was suggesting single CPU, very low amount of memory, and no GPUs at all. And well, this is a super simple algo, just trying to target average CPU usage, peak memory with some buffer, and so on, which is usually, honestly, pretty good enough for models being retrained every day. If you can keep track of the historical stats, you can feed that into this algo and use that in the recommendation. Looking at the server recommender algo, it will provide you an actual server type at a vendor. You can, of course, fine-tune and filter for a given vendor, or if you might be tied to a compliance framework like HIPAA, you can filter for the servers at a given region, which might be okay for your use case. This is also super simple, so it will just look for the cheapest server with the recommended specs, but of course, it can be fine-tuned, but this is the default one. If you're interested in more details, check out the docs. Hopefully you will find that useful. And of course, there are some ideas how to extend that. One of my main goals in the coming weeks is coming up with a central location for all the resource data collection so that you can point it to an S3 bucket or any other object store, and you can stream all the resource usage data there so that you can use your own script to analyze that data or use this package to do aggregates. This is super important, I think, for the standalone one, because if you are working with a framework which already supports artifacts, then you kind of have a solution for this, but it would be much nicer not to be tied to a single framework. So let's look at the Metaflow integration. Hopefully, this is familiar from the previous slide. So we have a flow specification. We have some steps. The only thing that I added is the track resources decorator being imported from Metaflow. So you do not even need to touch the resource tracker package. This comes with a Metaflow extension, so you can just import that from the Metaflow package. You add that decorator to any step, and then you will get these HTML reports generated for you with recommendations without any further tuning. So this is something I wanted to quickly demo. In the background, what's happening is that it's starting a resource tracker, and at the end of the step, either it failed or finished successfully, we'll call the render part. So this is time for a demo, although unfortunately, I wanted to use the Metaflow sandbox, which is a super nice way to get started with Metaflow, because the Outerbound folks provide this free sandbox, which is using Kubernetes in the background. You have access to this for free. You have VS Code running in the browser. You can code up some workflows and deploy that at scale to see how things are running. But this is offline today. I was not able to start it. This is the first time in the past 9 months that happened. So hopefully that will be fixed soon, and you can give it a try on your own as well. But I am not able to demo that. So what I did is I started a stack locally, which is honestly pretty easy. The Metaflow folks created a local dev stack that you can start with Tilt very easily. It's using Minikube in the background, spinning up all the required services. So Metaflow service, UI, and everything is running. You also see the user interface. So I will run this thing on my laptop and spinning up a few pods and see the related output. So this is a flow specification that I borrowed from the tutorial that is called Scale Out. And the idea here is that we would like to scale some of our steps to Kubernetes and not run our laptop or a shared server by using the Kubernetes decorator. Of course, you have to import that. And what I would like to do is also track the resources of this step. And what's happening here is that in the start step, we will create a list of 3 elements, and then we will start the process step and 3 separate processes requesting a lot of memory, which is a string made of X letters between 0 and 1 billion times repeated, and just logging the amount of bytes logged. This is a good use case for tracking the memory usage, because in the default docs, it was suggested to reserve 10 gigs of memory in Kubernetes to run this. All right, I've added the track resources and the Kubernetes steps, so I think we are ready to run this. And I'm running this scaleout.py locally, and hopefully things will be running fine. So you can see that this is a PID and some numbers here, which means that this is running on my laptop, and this is not looking good. But this was starting on my machine, and then it started to run things in Kubernetes. And we have an internal error. Okay, so I'm pretty sure I'm missing something obvious here. So if someone can point out what's that, I will be super grateful. What's that? Yeah, but this is an integer. So this should be like x repeated that number of.
Error that says something that they can't combine it with float in the terminal just now.
Oh. Okay.
Right there.
Random returns a float here. The first is type and multiply.
What's interesting though is that it's self-byte used. That's not even included here. All right. So I think, so this line is not even part of the script that I was editing.
I think we need to keep this bracket inside. I guess that's what other people are also saying. Like if you go back,
Okay.
this integer multiplying with random. If we try to close it here.
Just a second, because I think it should be running. I think it was just running an outdated version of this script, because if you look at this line, it's not even in here. So that was split up. So, okay. What's happening here is that you can see that some pods were created here, and the requesting a lot of memory string was printed a few times, and also the amount of memory that was requested. So hopefully things are actually running. Let's see if I go to this flow. So here's the start step. Then we go to process, and there has been 3 separate processes. Here I will click on one of these, which run for 9 seconds. Here you can see the output. It was supposed to reserve like 600 megabytes of memory. And you can see the auto-generated card here, which is showing that only around like 200 megabytes of memory was used. And then you can look into the details like, well, this is running on my laptop, and like 30 plus gigabytes of memory is being reserved. So the green line at the bottom is not really visible, but the main thing that I wanted to point out that it's barely using like a few hundred megabytes. So the default recommendation of reserving like 10 gigs just doesn't make any sense. And if you start using this thing, then you can see that it's totally okay to use a single gig, and you can save like 90% of the memory allocation in your future jobs. Sorry, this didn't go very well, but if you have time, check out the sandbox. That's a much smoother experience than trying to run things on your own, and this is a good service. Okay, regarding things that I'm considering doing, currently this thing is printing those HTML reports for you, so that you still need to take a look like what happened with your jobs, and you either take these recommendations granted and update your script to use this amount of vCPUs and memory, or we can actually fine-tune that and automate the resources decorator tuning, so that folks do not need to take care of that. We have implemented that at the previous role, which was super useful for the data scientist, so that they never needed to look at the memory allocation and the CPUs and GPUs and so on. If you're retraining things from time to time, like been seen that at fintech, advertisement technology companies and so on, then there's no need to waste time on it. The next thing is implementing the central location of storing this data and creating dashboards, proactive alerts if things are going wrong. What I would like to highlight is that this is not a general FinOps tool, so it's not for things running in 24/7, but specific for data science, machine learning stuff. When you are interested in the resource usage of your steps within a workflow, which is, I think, pretty specific. This is also not a profiler, so we are looking at the aggregated resource usage. We are only interested in where to place a job, so it's not for optimization and figuring out how you can make your script more performant or use less memory. It's just taking things granted, what you need, and it helps you find the best resource for that. So there are quite a things to be done in the future, and I'm super happy to hear any feedback from you folks. That's why I'm here. So if you have any related ideas, questions, please let me know. I know time is up, and break is coming up very soon, so I will just close now. But if you have time, please reach out either offline here in this conference. This is a good place and opportunity to chat. I happen to have a small booth down there next to the entrance, and I'm sitting there and looking for any feedback or questions. So please come there, say hi. I do have some holographic hack stickers as well for Metaflow and for spare cores as well, or otherwise just ping me online. Always happy to hear any feedback. So thank you so much.
This was a very nice and enlightening session. You guys can actually go to the booth later on, but still we would take at least 1 or 2 questions if you're comfortable.
Absolutely.
Yes, so very quickly, if people have questions.
So does this work with AWS right out of the box? So your batch decorator, if I use on my, like in my step functions, will it directly generate a DAG that runs on AWS batch?
Sorry, let me make sure I understand the question. So are you asking if this is allocating on AWS batch in an automated way?
Yes.
So if I may go to this example. So this decorator could be AWS batch as well. So this same stands just like for Kubernetes. The idea here is that the integration is already set up for Metaflow, so it has the credentials so that it can create the AWS batch, task definitions, and so on, or it can interact with Kubernetes to create the pods and so on. So that's already set up. Then here you are specifying the amount of memory, CPUs, GPUs used, which could be also broken out in a way so that you specify the resources this way. So first you define what is the remote executor, and then you can specify the resources with a different decorator, and then you can just replace batch with Kubernetes. So what this thing can do for you is that it's supposed to auto-tune this part so that you do not have to manually define the amount of memory or CPUs you use, and all the rest is already taken care of by the integration between Metaflow and the remote executor. If the question is that it can automatically add the batch decorator, so it can figure out if something can be run on the shared resource or it needs to be scaled out to remote executor, then the answer is no. Although it can be done from a technical point of view because this track resources decorator is already injecting other decorators. So it could be done. And honestly, I haven't thought about that. So thanks a lot for bringing that up.
One more question, or otherwise we're done?
We have one more question.
Thank you for the presentation. I was just wondering, you mentioned that the resource tracker package can be used separate as well. Just wanted to confirm on that. And also I was interested here, it was mainly focused on Python. Are there any plans to expand it also to other languages?
Yeah, so what I currently have is the Python package and an R package. But because this is looking at your resource usage outside of the process, either at the system or the process level, but by spawning a separate background process, it can be used to look at like anything. It can track Rust or it's not specific to any language, unlike the profilers. So it can be used to track resources of like any process on any machine, so should be doable. And if you're interested in how to do that, I included a few pointers in these slides, and happy to, well, I will post the slides as well, but this is it, what you need. You start this, and then you can do anything. You can also start this on the command line, and just you need to provide the process ID that should be tracked. Happy to come up with some more specific code if you can ping me later.
Thank you. Let's give another round of applause for our guest.
Thank you so much. Thank you.